All right, so we're down to the last main rule we need to look at. So just to recap quickly, I have angle in a semicircle is 90 degrees. The angle at the center is twice the circumference and vice versa. Angles on the same arc are equal, that come out from the same arc. Cyclic quadrilaterals with all 4 points resting on the circumference. The opposite angles on that gonna add up to 180. And we just learned about the tangent, where wherever the radius meets the tangent, you're gonna get 90 degrees. And a lot of the times we have two radii meeting two tangents looking like a kite shape, and it turns into a similar cyclic kind of quadrilateral where the opposite angles add up to 180, which we saw in the last two questions. So the last rule that we have to look at is one of the hardest to spot, but it has to do with a tangent as well. You must have a tangent, and the rule is once we have a triangle, so you have to have a triangle and a tangent, nothing to do with the four-sided shape now. So once I have a triangle resting on the tangents, and again, it could look differently, it might look differently in different questions, and we're going to look at some of those different questions in a little while. So once I have the triangle resting on the tangent like that, they call this the angle segment theorem. Angles in alternate segments are equal, so whatever angle I have outside the triangle resting on the tangent is going to be the same thing inside. So for instance, if inside the next side as well, because it's both sides it's applied to, let me just say here is 50 degrees, then opposite inside angle, that's the opposite inside angle. I'll draw in my arrow, and you'll see it's in the virtual package as well. That's also going to be 50 degrees. Let me see it better with a question though. So that's it. Once we have a tangent, have nothing to do because we don't have a center of the circle. This does not have a radius, if you notice. So we don't have that opposite angle there. So the first one we're going to look at is May 2009. Hopefully you could see it there. So this is the diagram. I'll zoom out in a little bit to see any question part not showing as much. I'll see if I could lift it up so we can see it a little better. So the diagram below, not drawn to scale, shows a circle center O. So we do have a center of the circle. The line DCE is a tangent. So we have a tangent. Angle ACE is 48. ACE is 48. That's what they give me here. OCB is 26. OCB is 26 degrees. And I want to find different pieces. And we'll just go up a little bit and see if all fit in. Right, I want to find these different pieces here in this question. 6 pieces from 2009. So let me see if I can notice anything myself first, right? I have a tangent. Is there any radii meeting the tangent? This time I only have one radius meeting the tangent. Any line from the center of the circle to the circumference would give me a radius. So I have a radius here. I also have a radius here, obviously. So automatically these two lines equal. You realize we already have these are things I want you to notice when you're looking and analyzing your diagram. That we have two radii here, meaning this automatically is isosceles triangle with these two angles equal. We'll come back to that in a little while. These are things that are just jumping out to me as I look at the question. And same thing here. We have a radius meeting a tangent, meaning a 90 going to shoot out here. But a 90 only going to shoot out on the next side as well, because in a triangle, in a straight line, 90 at 90 is 180. A straight line is supposed to add up to 180, one of the basic geometry rules. So because this side is 90, the other side going to be 90 as well. So it'll just be one side is 90, right? Obviously 90 at 90 going to give me 180. So already certain things done jump out to me already. This whole thing here have to total 90. So he contributing 26 at the 90. So this angle here have to contribute the rest. So here going to be 90 minus 26. 90 minus 26. Here is 64 degrees. Same thing here. This whole thing have to be 90. He contributing 48. So he have to contribute the rest to make up the 90 on this side. Again, 90 and 90 is 180. So this angle inside here going to be 90 minus 48. 42. But we just say this is isosceles because the two radii are equal. You see how everything just kind of falling into place one after the next. So here's 42, here's 42, and then I could find here. Right? In a triangle, supposed to add up to 180. 42 add 42. So far they put up 84. But a triangle is supposed to be 180. So you have to make up the rest. They put up 84, 180 minus 84. Here going to be 96. And if you notice, we have one pair of lines going to the center and the next pair going to the circumference. So wherever the center is twice the circumference. So here going to be half of 96. 48. And look how much angles I get. Let me see if I just so happen I get all. I didn't get all, but let me see what the question had asked for to help me start off. So the first thing they want is angle ABC. You notice what happened there in angle A, triangle ABC, sorry, angle ABC, ABC. That was the last angle I get. Why did they ask for it first? That was the last angle I get. When I do all of this, that was the last piece of the question I get. However, they asked for it first. And even though the answer is still 48, it's something I want you to notice specifically with this one. And I'm going to highlight it. Remember that rule I just looked at just now? That rule here. And that's why they're asking for that first. Because I have the tangent, and if you notice, I have a triangle resting on the tangent. Like I said, sometimes it's be a little harder to see. You could have worked around it still, but don't forget that sometimes you could have, we didn't really need it this time because I could have worked around it. But if I had seen that first, that we have the triangle resting on the tangent, which again is this last rule I just talked about. This rule says that whatever angle I have outside the triangle resting on the tangent, it's going to be the same exact thing on the opposite inside. So that's how both of those end up being 48. And you realize I didn't need any working for it. That's the angle segment theorem, that the angle outside is going to be the opposite inside. And then I could have worked backwards. If here is 48, then the angle at the center is going to be twice 48. 2 times 48, because the angle at the center is always twice the circumference, because I have the circumference now. 96. And again, I could have chipped away at it like that if I had liked. Let me see the other pieces that they want. They wanted after that one. Again, I don't have to do it in order as well. I could do it in whatever order I saw it in. Angle BCD, BCD, and again, it don't make sense knowing how to get the angle and still don't know how to read out these 3 letters. BCD means B to C to D. That's the angle at form. We have that already. And if you want, you could put your work in. 90 minus 26, that's 64. To at least show them you know how you get the answer. Or if it's on the diagram already, that should be sufficient. Next one, angle BAC. BAC. So BAC, if you notice, is this big piece here. BAC covering all of this. How are we going to get angle BAC though? So the same way I just got that last angle, again, I have different ways to get it. And I'll do both ways. The shorter way would have been if you had noticed that just like on this side, I'm a triangle, the opposite interior are going to be the same. Same thing on this side. Opposite this side, this piece here going to be the same. So that BAC should be 64 degrees. Okay, I didn't notice that triangle rule. Could I work around it? In this question, yes, I can. And I'm going to redraw the triangle right here just to show you. So this is the triangle I have inside there looking something like that. We know this angle up here is 48. This is B. We have A here and C here. Now C split in 2 pieces right now with 26 and 42. So the 26 and 42 are going to give me 68. 26 and 42 because those 2 angles combining to give that big angle there. And then I could just add up these 2 because angles in a triangle have to add up to 180. So both of them put up 68 at 48. 60 at 40 is 100, 8 at 8, 16. So both of them put up 116. So here to make up the rest. 180 take away 116. So you see how I still get the 64 degrees. But if I had recognized that rule, I would have get it immediately and didn't have to do all of this extra working. Angle OAC. OAC, well, we already know that this part was 42 because it's a isosceles triangle. And once I get 42 here, I could get the 42 here. And the last part was angle OAB, which is this tiny part here. So now, we know here is 42, because remember this angle splits into 2 pieces. We know here is 42 degrees. And the whole thing is 64 degrees. The big angle is 64. This part is 42. So that part inside there will be 64 degrees minus 42 degrees. 22 degrees. Right? So again, this piece was 64 and both of these have to make up the 64. This part is 42, so he's going to make up the rest. And again, this was a very detailed question, even though each part was, it was 6 marks by the way, each part was only 1 mark. But it was a nice summary of most of the rules as well. Let me look at one more. This was a harder question for a lot of students the year it came. And the reason why it was a harder question, all the nice regular rules weren't there. So some of the popular rules was, even though I do have a tangent, this circle had no center, and because the circle had no center, it had no radius meeting the tangent to give me the extra 90. It also had no angle at the center, was twice the circumference, because I have no center. I need to have a center to have the radius, or the angle at the center is twice the circumference. So those two most popular rules weren't there, so we had no choice but to use some of the other rules. So let me see what the question had asked for in May 2010 for 7 marks. Diagram below, PQ is a tangent. This is not a tangent. QRT is not a tangent because it pierced the circle. A tangent must rest on the circumference. So once you get a tangent, don't forget that it's 2 rules you have with the tangent. And most likely you're going to use one of them. If I don't have the radius, that means I probably have to use this rule, and we'll come back to that in a little while. Right, PQ, we have circle PTSR, angle RPQ. Where is RPQ? RPQ is this angle here, is 46, and RQP is 32. And again, they say TRQ is a straight line. Anything jump out here at the beginning? It don't have to, but if you notice, this is a triangle. And in a triangle must add up to 180. He put up 46, he put up 32. 46 and 32, so far they put up 78. So that means this piece here have to make up the rest of the 180. So here going to be 180 minus 78. So here going to be 102 degrees, and any angle on a straight line also have to add up to 180. So here going to be the difference, which was the 78. All right, 180 take away 102, 70. So that's what I have so far. I don't have any parallel lines, so I can't say this is a Z shape or anything like that. Have no way to get those. What I have to notice is, because I have a tangent, I should look, if I don't have the radius rule, I should look for this rule with the tangent, because they wouldn't usually just give you a tangent for so. One of these rules might kick into play. So this is what I'm looking for. Are you seeing this situation though? It might be a little harder to see. Is there a triangle? Well, it looks like they have 2 triangles, but only one touching the tangent. So I'm going to highlight that triangle that touching the tangent. Because remember, for this rule, I have to have a triangle touching the tangent. I do have a triangle touching the tangent, and unlike that rule that I showed you earlier, this time it's upside down, and I could orient my diagram like I want. So that's the same situation I have here with numbers this time. So the rule is, whatever angle I have outside the triangle on the tangent, that's the same thing going to be opposite inside. So because here's 46, the opposite inside also going to be 46 degrees. Like I say, it's a little harder to see, but the more questions you do, the easier these things become to see, because you get accustomed looking for them. So again, once I have a tangent, 2 rules apply. Radius meeting the tangent. Oh, no radius in this question, so let me jump to my next rule. And in this next one here, now that I had all them background pieces, that was the first part, by the way, angle PTR, 46 degrees. Next one, angle TPR. TPR, well, guess what? Because I found all these extra pieces earlier, which I could have basic geometry, how much the triangle is add up to, angles on a straight line. I have 2 angles now in my triangle. Here's 46, here's 78. When I add them up, I'm going to get 124. Right, 78 at 46, 124. So here I have to make up the rest. So this angle in here is going to be 180 minus 124, which is 56. And again, I could show more working either up here or in the body of the question itself. So here's 56. How am I going to get my last angle though? Angle TSR. Let me see where angle TSR. TSR looking like it's in the next triangle. But it's not really a triangle I have. And like I say, you have to train your eyes to see these things. Did you notice we have a cyclic quadrilateral here, meaning all 4 points touching the circumference? And again, I'm just going to highlight it now in my Hulk green color here. Right? So all 4 points touching the circumference, meaning opposite angle is going to add up to 180. So these two are opposite that I want to find. And it just so happened I find out here was 56. So the opposite angles have to add up to 180. So he's going to be 180 minus 56, 124 degrees. And that's what these questions look like. We're going to try the most recent questions in the next video.